We're basically going to do the exact same thing. Example number 2 wants us to solve these inequalities through graphing. All right. So let me show you what we'll do. We have 2x minus y is greater than or equal to negative 3. And then we have y is greater than or equal to negative 1/2 x plus 1. Okay. Now if I take this first equation and I solve for y, I get this equation. I get y is less than or equal to 2x plus 3. And then this one just kind of is already written in that way. It's written as y is greater than or equal to negative 1/2 x plus 1. All right. Now, I'm going to sketch this, then we'll do it on a graphing calculator and see how accurate we are. If I were to graph this,
those are perpendicular lines.
well, let's see.
Anonymous person. Good job.
Let's graph the first line, okay? So if I graph this first line, just graph it like a regular line, what's the slope? 2. What's the y-intercept?
3.
So I'm going to go up 1, 2, 3. That's my y-intercept. Then I'm going to go up 1, 2 over 1.
Not parallel, they're perpendicular.
Yeah.
Guys, you're focusing on the wrong thing. We're trying to find the solution set. We don't know if they're parallel or perpendicular, although we do. But that's not the question I'm asking you. Okay? They are perpendicular for those of you playing at home, but I need you to pay attention and focus. That's not the solution to the set. So if I draw a straight line, why am I drawing a straight line? Can somebody answer me that?
Because all lines are
Because it's a lot later.
It's a great philosopher.
Why am I drawing a solid line?
It's less than or equal to.
Because it says
Because of this equal to symbol, right? If that equal to symbol wasn't there, I'd draw a dashed line, right?
Yes.
Okay. So I'm not drawing a dashed line. So that means I'm including all the x and y values on the line. Does that make sense?
Yeah.
All right. So now let's do the second one. The second one, I have a y-intercept of 1, and then I go down 1 over 2. So I'm going to have a line that kind of goes like this, except straight. Okay? Now, what I'm looking for is where these two overlap. So I'm going to go back to my original equation. This one here, it says less than. Y is less than this value. In other words, y is going to be the shaded region below the line. So what Mr. Adams does is I just draw short little lines underneath my graph to let me know that I'm shading the whole region below that. Now, for the green one, y is greater than. It's a solid line because I have the equal sign, but because it's greater than, it's going to be the region above the line.
Yeah.
So now, what I'm really interested in is where the two overlap, because that's the solution set.
Everything in there is your solution.
So where these two overlap is my solution set. Does that make sense? Now, I want you to do it by hand this way. I want to see it on your homework this way. I want you to graph it this way if it asks you to graph in your homework. Now, if you want to double check it, what you can do is you can just simply go to my graphing calculator and plug it into the graphing calculator. So what we said was the first equation, and actually graph it using the inequality given to you in the textbook. Okay? Don't graph what you solve for y. Graph it using the inequality from the textbook. So I've got two of them. The first one is 2x, right? 2x minus y is greater than or equal to negative 3. That's the first one. And then the second inequality is just going to be negative 1/2. So I'm going to say minus, in parentheses, 1 divided by 2, close parentheses. I guess I could have just put that. Times x plus 1. And hey, that looks just like mine. But I gotta make it.
Your inequality.
Oh, I gotta graph it. I forgot the y stuff. So I'm gonna say it was y is less or greater than or equal to those. Greater than or equal to those. So now, guess what? Where the two overlap is just like what I've drawn on my board. Does that make sense?
Yeah.
Okay.